I'm Anil Kumar. Welcome to my series on percent, fractions and percent change. This video is good for all the students who want to begin with understanding of percent and fractions relations. Now this is a very important concept which really helps you to solve many types of questions, and this video should be excellent resource for all the students who are taking multiple choice test exams like SAT. Now in this particular video, we'll basically concentrate on how to convert percent to fractions and how to convert fractions to percent. We'll find percent of numbers and kind of introduce you to the concept of calculating percent increase or decrease. At the end, I'll give you a table which will relate percent to fractions for most of the numbers. Basically, the idea here is to see how 1 over any number could be written as a percent, right? So like 1 over 8 is what percent? You should know it by the end of this video. That's the target. Now if you have any questions or if you need any suggestions, you can always email me on the given address. So now let's see how percent is related with fractions. So in the very first part, let us convert percent to fractions. To understand better, percent is a fraction with denominator of 100, right? This is the basic thing. So if I say 20%, so 20% basically means we have to, if I write percent as 20%, it basically means 20 out of 100. So that is what percent is. Now as soon as I write 20 out of 100, you could simplify this, right? You could simplify this, you could cut like this, and equivalent fraction, if you remember, you could write this as 1 over 5, correct? So I could write 20% as 1 over 5, and so I can also say that 20% is equivalent to 1 over 5 in fractions. Does make sense to you? That's the whole idea, right? So if I take 40%, for example, 40% means what? 40 over 100, right? So if I do my calculations right, what should I get? Well, you need to do all this, but what I will do here is, since I know 20% is 1 over 5, 40% should be twice that. So that should be 2 over 5. Does it make sense to you? See how automatically things come, and that is how we have to evolve our thinking, and that is what my idea is. So if I take this as 60%, then that means really it is 60 over 100. Well, I could simplify this fraction in the manner I did, or I could just correlate it with 20%, which is 1 over 5. 60 is 3 times 20, so it should be 3 over 5. Does that make sense to you, right? So that is how we can actually build our vocabulary about percent. Perfect. So let me just write 80% also here and see how easy it is to really relate percent with fractions, correct? So 80% should be 4 over 5. Perfect. So easily we could convert all these percents into fractions. Do you see how easy it is? Now let's look into another category of percents. For example, if I say 75%. Now 75% is what? 75% means out of 100, right? Let's say you got 75% marks. That means you got 75 out of 100. That is what it means. Perfect. Now, you can divide them by 25, quarter of each. And what you get here is 3 over 4. So it is so simple. So you could think in terms of currency, right? Quarters, dimes, right? They can help you to convert or relate percent with fractions. Does make sense to you, right? Now, let's take up some difficult examples. So slightly difficult would be if I take 45%, right? So what is 45% equal to in terms of fractions? Well, both can be divided by 5, right? So this could be written as 9 and this could be written as 20, right? So that is 45% should be equal to what? So 5 times 9 and 5 times 20. So it is equal to 9 over 20. Does it make sense to you? Right. So we could actually get results in this fashion. Now, we could also have percent which is more than 100, right? So 100% is 1. If I have 100%, so 100% means what? 100% means 100 over 100, correct? So 100 over 100 is 1. So one number will be treated as 100%. Now, what could be 125%? Well, 125% is more than 1 and it should be how much? We have to divide this by 100 and then write down the equivalent fraction. I could divide both by 25, 25 times 5 and 25 times 4. So 5 over 4. So these are improper fractions, higher numerator than the denominator. Perfect, 125%, 5 over 4. So in percent, you can get numbers more than 1. You get an idea, right? So sometimes we also use percent to fractions to decimals. I'm actually not getting into decimals in this particular video since we could have done very easily 125 could have been written as 1.25. However, it is not very easy to write all numbers in decimals, right? So anyway, when you're converting percent to decimals, it's very easy since dividing by 100 means moving decimal 2 places, right? So I've not taken that up, but that is kind of very simple, right? You can understand dividing by 100 means moving decimal 2 places. So at times you could also write this as decimals. Does make sense to you, right? Okay, now here is something very interesting. If I write a number which is, let us say, let's give me an improper fraction here. So if I write, let us say 62.5%, this is difficult, right? 62.5%. Now, how do you convert this to fractions? Then it becomes difficult, right? So we'll take more of these kinds in our part 2. But initially, let's try to understand these simple examples. Do you get an idea, right? So, well, 62.5 also can be done as fractions. The only thing here is we have got decimal involved, right? So you could think like 625. Let me first write this 62.5. So we are giving 625. Percent means 100. Now since there was decimal, we increase 1 0. You get an idea, right? So what we really did here was that since the number 62.5, so first we could write this as 625 over 10, but over 100 means it becomes 1000. Do you see that one decimal place makes it kind of like this? And now you could actually divide and then get the result, right? So if I do with, let us say we divide this by, let's say 25, what do you get? So if you divide by 25, then denominator, 25 times 4 is 100, so we get 40 here, correct? Now, 25 times 2 is 50, right? 50, and then you get 125, which is again 25. 25 square is 625. That is how you could also relate this too. Now, this could be further simplified and written as what? Both can be divided by 5. So if I divide this by 5, I get 5 here, and this is 8. So we get 5 over 8. So 62.5% is 5 over 8, right? So sometimes it could be complicated, but it doesn't really matter. You could still write this as a fraction. Let's understand this once again, how I wrote 625 over 1000. Let me explain you here. We had 62.5%, right? So that basically becomes 62.5 over 100, right? Now, I want to avoid this decimal. So, means I have to multiply both numerator and denominator by 10. So, I get 625 over 1000. Does it make sense? That is how I got this 625 over 1000. And then I kind of simplified in steps. Perfect. So, I hope that makes sense to you now. But in any way, you learn how to convert percent to fractions. The only thing is just divide by 100 and simplify in lowest terms. So that is the key. So percent is a fraction with denominator of 100. Very simple. And then what you really do here is simplify to lowest terms and then convert to lowest terms. Right? Now, let us see how to write fractions as percent. I hope this part is absolutely clear, right? Let's move on. Now let's look into conversion of fractions to percent. So as we took last time, few simple examples. We'll begin with very simple stuff here. So we say we need to simplify a fraction and then multiply by 100 to convert a fraction to percent, right? That is the key. So if I write a number, I'm writing numbers already in simplified form, like 3 over 4, right? It cannot be simplified further. Well, we will take numbers like half, okay. We can take numbers like 15 over 60, right? So let's begin with these numbers. Now, if I have to convert this to percent, 3 over 4 is a fraction. How to convert this into percent? To convert to percent, we have to multiply by 100, correct? So that is the key. So when you multiply a fraction by 100, you get percent. That's the whole idea. So we know this, that 100 can be divided by 4, 25 times, and 3/4 is 75. And therefore, 3 over 4 is 75%. Perfect. So that is how we will be doing. Next one, half. Just multiply by 100. So it goes 50 times. So 50%. Right? 15 over 60. Think about 15 minutes as a percent of an hour. So this is like an example. It is 15 minutes. Right? And we are dividing it by an hour. Right? So what percent is 15 minutes of an hour? That is the question for you. Example, right? So we have to multiply by 100. Now this multiplication, you could do it in a couple of ways. You could first simplify this and then do it, or you can do all together, right? I prefer to do it all together since we have more options to simplify. Perfect. But anyway, let's simplify this. Dividing by 5, I get 5 times 3, and 5 times 1 and 2, 12. And now dividing by 3, we get 3 times 1, 3 times 4. And we know 100 over 4 is 25, correct? So 100 goes with 4 25 times. So we get 25%. So that is how you could easily convert any fraction to percent, correct? Let's take some more examples. So if I take a number 5 over 6, you need to convert this to percent. And let's take a number 1 over 8, right? Convert this to percent. You can actually pause the video now, try it yourself, and then look into my suggestions. So here is 5 over 6. You're going to multiply this by 100, right? So when you simplify, what do you get? Well, this could be divided only by 2, remaining 3 here, and we get here 50. Now, we need to write it in decimals to get to percent. Do you get the idea? So it is not kind of as direct as it was earlier. So we can now multiply 50 by 5. So we get 250, and we need to divide 250 by 3 to get the equivalent percent. You get an idea. So at times, you may have to divide your numbers as I'm going to do now. Now, 24 is 3 times 8. So it goes 8 times. We get 24 here. Remainder. Take the difference. You get 1 and 10 from here. 3 times 3 is 9. Right? 3 times 3 is 9. and dividing, taking away 9 from 10 is 1. Now you need to convert to percent. You can go 2 decimal places or 1 decimal place, correct? So bring down 1, we get 3 times 3 is 9. Again, you have 1 remainder, correct? So you see, it never stops. It kind of continues, as you have seen right there. So 5 over 3 times 100, you cannot really find a number as easily as we found earlier. So in this case, you do long division. We are trying not to use a calculator, correct? If you use calculator, it's kind of simpler. 250 divided by 3, it gives you the fraction which could be converted as 83.333 recurring, as we are getting, right? You could do that. But I will suggest try to do it with long division and do this exercise without calculator, correct? Now we could write this as 83 is the whole number, right? And what you see here is 1 remains, right? So we could write 83 1 over 3%. So you could also write this into mixed fractions, because the exercise is to write as a percent. You have a choice. You could have written this as 83.3 recurring percent, but this is more exact. So we'll call this as our exact answer. So whenever you are converting fractions to percent, you need to write the exact answer. So in this case, 5 over 6 could be written as 83 1 over 3%. You get an idea, right? So 1 over 8 also will be something like this. Let us see. So if I multiply this by 100, what do I get? Well, I can divide both by 4 times 2, and this is 4 times 25. So you need to divide 25 or half of 25. You know it is 12 and a half, right? So you could do, let's continue with the process. So when I divide by 2, I get 1, 2, 0 remainder, 5 taken down. So it becomes what? 2 times 2 is 4 and 1 is my remainder. 1 is the remainder, quotient is 12. So I could write this as 12, 1 over 2, 1 over 2%. You get an idea. So we could write a fraction as a percent in the form of a fraction, a mixed number also. Perfect. That is the exact value. You get an idea, right? So in this particular case, you could have also written this as 12.5%. However, both ways should be known to you. That's the whole idea. Got it? Now, as an exercise, you could try what is 7 over 8 equals to. So 7 over 8 will be what? Right? It will be definitely 7 times 12.5. Correct? So if you want to know that, you could write this as it is, we'll do a simpler form, right? So we will say that is 7 times 12.5%, correct? So we could write this as 7.5 gives you 30, 7 times 5 is 35, gives you 3. 7 times 2 is 14 and 3, 17. 7 times 1 is 7 and 87.5%. You get an idea? So you can sometimes use your results to get new results. Does it make sense to you? Perfect. So you could do that, right? Otherwise, the option is always open for you. You write this number 7 and divide it by 8, right? So, of course, you have to multiply by 100, 700, divide by 8, right? Now, if you do that, 8 times 8 is 64, right? So what you get here is when you borrow, you get 60. Now, 8 times 7 is 56, and the remainder is 4. Now, 4 is your remainder. You could write this as 87. This is the whole, 87. 4 is the remainder, 4 over 8 as percent. Now, this is 87, 4 over 8. I could simplify this and write this as 87.5%. Does it make sense to you? So that is kind of practice which we will do in part 2. Correct? But I'm kind of giving you an idea that we'll have examples which will be slightly more complicated than we are taking in this part. Once you get conversant with the basic process, Then we'll get into harder questions like this in our second part of the video. But I hope you understand and appreciate where we are going, right? So by practicing this kind of conversions, remember one thing: write your answers in the exact forms, maybe a mixed number that is preferred than the decimal numbers, right? Okay, now let's move on and take the next concept, which is basically how to find percent of a number. Let's take few examples and see how to find percent of a number, right? So let's say we need to find what is 40% of 80, right? Let's try to figure out, right? 40% of 80. Okay, let's take a simpler example. 25% of, let's say, a number 120. How do we solve such questions? When I say 40% of 80, percent, as you understand now, is 40 over 100, right? That is the meaning of 40%. Of will translate to multiplication sign and the number 80, correct? So you get this 40% of 80. So that's your mathematical language. So that is how we can treat this as a phrase. And in mathematics, we'll write this as 25% means over 100, of means times 120. Does make sense to you? So that is so simple. That is how you find percent of a number, right? So if you write like this, you're writing it as a fraction and then doing it, right? You could also write this as a decimal number and then do it. So alternate could have been, let me use a different ink here. 40% means 0.40, of means times 80, right? So that is also correct. 25% means 0.25 times 120, right? So both are same things, correct? So both are same things. You could do either one of them. Okay. Now the next question is, we need to just simplify and write them as their equivalent. So I leave this exercise for you. Now, if I use, let me show you how the fractions is better. Well, there is nothing called better. If you work with decimals, you say 0.4 times 8. This is simpler. So in this case, 40.4 times 80, when you multiply, you get your answer as 32, right? So you get 40% of 80 as 32. In this case, 0.25 times 120 could be difficult, right? But this part may be simpler. 25 over 100 is like a quarter, correct? So in this particular case, we may prefer to work with the fraction which is quarter of 120. Do you understand? So sometimes one process is better, sometimes the other one. And therefore, you should be familiar with both. So 1/4 of 120, half is 60, and then we get half of that, 60 half is 30. Does it make sense to you? So sometimes what you notice is working with fractions is better, and sometimes working with decimals is better. So as the case may be, you can actually change your approach. You need to be flexible, what I'm trying to understand, right? So that is how we see it. Now 1/4 is 25%. You could have gone direct also, just as you wrote 40% is 0.4, right? Let's take another example of finding percent of a number. If I give you 75% of some number, let us say 75% of 16, how will you do it? Well, you have two options. You could use 0.75, of means times 16, get your answer. Or what you could do, 75% you know is 3 over 4, right? So in fractions, 75% is 3 over 4 times 16. You can get your answer. You decide yourself which is better. Well, I find this simpler. 4 times 4 is 16 and 4 times 3 is 12. So we get our answer as 12. So both the approaches are very good approaches to solve for percent of a number. Does it make sense to you, right? So that is how we are going to work for now onwards with percent and numbers to find percent of a number. So understand the statement. when I say 40% of a number, it really means 40 over 100 times that number, right? As we were saying, we could also find 125% of some number, right? Let's say 125% of 20 is how much? Well, 125% we wrote as fraction as 5 over 4. Do you recall? So I'll prefer this to work with fractions. Of means times 20, right? Now you could really simplify this, and then you get 4 times 5, and the answer is 25. By now you must have realized that in most of the cases, working with equivalent fractions is far, far better. So if you really want to answer a question very fast, the approach which you should take is to understand how to write percent as a fraction immediately, right? With practice it will come. And then use fractions to get your answer. If you adopt this approach, you are going to be very successful with multiple choice questions, right? So I hope that makes sense. Okay, so let's move on and now take up the next concept. Now we will talk about percent increase. Now when we say percent increase, it means change over original times 100. So that is the basic formula to find percent increase. You could use the same formula for decrease also. Change could be positive or negative. So if it is percent increase, your answer will be positive, right? So that is what it is. So it increases from some value to some other value. Now let's try to see how to calculate percent increase. Let us say that the cost of a book has been increased from $5 to $10, right? So what is the percent increase? And we need to find what is the percent increase. So here, what is the change? Look for the change. Change is basically final minus original. So here the change is 10 minus 5, which is $5. Correct? So we get the change, and therefore now we can say percent increase is equal to the change over original times 100. So in our case the change is positive 5, original was also 5, right, times 100, and that gives you 100%. So the same amount, the whole amount, $5, right, it has been marked up by 100%. So we also say, in other words, if it is the cost of a book, we will use the word markup by 100%. So when I use this term markup by 100%, it means the price has been increased by the same amount, right, as the cost itself. Do you get an idea? So we are introducing you to another concept where percent fractions and all this, percent change, will be of huge importance to us, right? Now, let's take another example. In this example, we saw that the change was of $5, right? Let's take another change of $5. Let's increase the price from $10 to, this time, $15. Now, can you find the percent change? Well, the percent change will be how much? Let's do it in one statement. Final price is 15, take away 10, divide by the original price of 10, and then times it with 100. Does it make sense to you? It is that simple. So we get here 5 minus 10 is 5 over 10. So we could actually cancel this, right? So we get 5 times 10, and it is 50%. Simple as that, correct? So at times you can just do it direct. But the important thing to note here is, I hope you have noticed, that is the percent increase of $5 here made a change of 100%, right? and in this case it is only 50%, since the original cost was $10 and now the $5 is on 10. Earlier the 5 was on 5 and so it was 100%. Correct? Well, let's go a step further to really appreciate this process, and that is if I increase the price from $20 to $25. Now, what do you expect? Will it be 100% change, 50% change, or lesser? It has to be lesser, right? So in this particular case, what should be the change? Let's calculate. Now in this case, the percent change should be equal to 25 take away 20 over original price of 20 times 100, right? So that gives you, this goes 5 times, right? And here we have 25 minus 5, right? 25 minus 20, which is, sorry, 5 I should have written here. Okay, so this is 25 minus 20, which is 5. So it becomes 5 times 5, which is 25%. Does make sense to you? So here, the same $5 increase results into 25% change. Right? So what do you conclude, which is a very important thing to understand? Let me make a note of this. Increase by same amount can result in different percent change. This is very important. Why it is so? Because the original amount is different, correct? So in the formula, even if the change is same, if the original amount is different, of course, you are going to get different answer. If the change is same for higher amounts, then lesser the difference. You get the idea. So I like you to think about percent change as the change over original amount times 100, and also understand the concept that a change of $5 over $5, $10 or $20 is not the same. Perfect? Okay, so with this, let's go to the last part of our video, where we'll take up percent decrease or kind of discounts which you get for shopping, right? Okay, so in this case, we'll calculate the percent decrease. As you will recall, percent change is could be positive or negative. When the percentage change is negative, we say it is percent decrease, and that is always equal to change over original amount times 100, correct? So let's take few examples. So this time we are decreasing the price of a book from, let's say, $50 to $40. Okay, so if I do a decrease, what happens? Final change is always final minus initial over initial. So I'm using a different term, initial instead of original, right? But it means the same thing. Final is $40 minus the original, which was 50, divided by 50, right? So times 100. So that gives you, this could be simplified, times 2. So you get here minus 10. Do you see that? Minus 10 times 2. And that results into minus 20%. So this minus means decrease. You see decrease? Because of this negative 5. Decrease by 20%. So this price, so that means there was 20% off on the cost of the book or selling price of the book, right? So that is what is the concept. So percent change is the huge concept which we are going to apply working with many practical examples, correct? Now, just going one more step here, let us say this change would have been not from 50 to 40, but from $20 to 10. Still, a change of $10, right? Will this be higher or lower? Do you expect negative 20, 30, 40 or 10 or what? Estimate. Well, in this case, the percent change will be how much? 10 minus 20 over original amount of 20. We see the difference is same, however, you are dividing by a smaller number, right? So you get higher number as a change. So 20 goes 5 times, correct? Now this becomes a 50% change. Do you see that part? So if there is a same change of $10, in both cases the change is equals to $10, correct? But here percent is 20, here is 50%, since the original cost was lower. Perfect. Now here is the exercise for you. Let's say somebody has decreased the weight, let's say pounds. Let's go to weight now. So weight loss from, let us say, 210 pounds to, let us say we have 180 pounds. Find percent change. So definitely there is a decrease. I would like you to write down the answer in the comments, right? So I hope that's fair enough. And write your answer in the simplest form, okay? So try this out. If there's a weight loss from 211 pounds, let's make it simpler, 210 pounds to 180 pounds, then what is the percent change, right? So I hope with this you understand and appreciate how we can work with percent, right? So this is a very important exercise. Now in the next video, we'll talk about more percentages, and here is how we are going to see it in future. As an exercise, what you can do is, you can practice converting all fractions 1 over 2, 1 over 3, 1 over 4, 1 over 5 into their percent equivalent, right? And make a table just as I have created here. This kind of a table is going to help you a lot to work with percent ratios, percent increase and related questions, right? So once you look at it many times, you will understand 1 over 20 means 5%, 1 over 24 means 4, 1 over 6%, 1 over 25 is 4%, correct? So anyway, so have a look at this table, try to create one for yourself. That is going to help us for the future videos and understanding the concept. So in part 2, we'll actually work with this table and see how we can actually quickly solve many questions related to percent. I hope you find this interesting and useful. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.